All right, let's get right into it. We're about to explore one of the deepest, most mind-bending mysteries in the entire universe. We're talking about the invisible stuff that, believe it or not, is holding everything together. Welcome to our guide to dark matter.
So just start with this question. What if everything you can see, every star in the sky, every galaxy we've ever photographed, everything you've ever known, what if all of it is just a tiny, tiny fraction of what's really out there?
And this really puts it into perspective. This is basically the recipe for our universe. A massive 68% is something called dark energy. A whole other mystery for another day. But look at that next chunk. 27% is dark matter. And that little sliver, that tiny 5%, that's us. That's all the stars, all the planets, all the atoms. Everything we've ever seen. The other 95% is a complete unknown. So how on earth did we figure out that something was missing in the first place? Well, this is where the cosmic detective story really begins. Astronomers were just looking at the universe, doing the math, and they realized the numbers were wrong. Seriously wrong. And this was the first huge clue. Back in the 1970s, an amazing astronomer named Vera Rubin was watching galaxies spin, and she noticed something that just shouldn't be happening. They were moving so fast that according to everything we knew about gravity, they should have just ripped themselves to shreds, flinging all their stars into the void. But they weren't. Something invisible was holding them together.
Okay, so think about it like this. Picture a merry-go-round. The horses on the very edge move slower than the parts closer to the center, right? Well, galaxies are supposed to work the same way. The stars way out on the fringes should be moving slower, but they're not. They're whipping around just as fast as the stars in the middle. And the only way that's possible is if there's this enormous invisible halo of mass surrounding the whole galaxy, adding a ton of extra gravity. It's like a gravitational safety net we can't see.
A whole galaxy spinning too fast is a pretty big piece of evidence, but you can't build a whole case on just one clue. So scientists started hunting for other fingerprints left behind by this invisible culprit.
And luckily, we had the perfect tool for the job, thanks to Einstein. His theory of general relativity basically tells us that massive objects don't just pull on things, they literally bend the fabric of space and time itself. And when space bends, so does the path of light traveling through it.
And this is where it gets really cool, because when we use our telescopes to look at really, really distant galaxies, we see their light getting warped and distorted, almost like we're looking at them through a giant invisible magnifying glass. The thing is, when we add up all the mass from the stuff we can see, it's not nearly enough to cause that much bending. There has to be something else there, something massive and invisible that's warping space-time.
So, the third major clue takes us all the way back to the beginning, to the history of the universe. According to all our models, right after the Big Bang, all the normal matter we see just didn't have enough gravity to clump together as fast as it did. The universe we see today, with all its galaxies and clusters, formed way, way too quickly. It would be impossible unless there was already an invisible scaffold waiting for it. The leading idea is that dark matter, because it doesn't get pushed around by light and radiation, started clumping together way earlier. It formed this gigantic, invisible cosmic web. And then all the normal matter simply fell into that pre-built structure, creating the galaxies and clusters along these invisible filaments.
All right, so the evidence is pretty overwhelming at this point. There's some invisible stuff out there, and there's a lot of it. But what is it? Well, it's time to check out the lineup of cosmic suspects.
We've got a few interesting characters here. For a while, people thought it could be machos, things like rogue black holes or super dim stars. But we've looked, and there just aren't enough of them. Then you have the more exotic ideas, like super-duper light particles called axions, or maybe a heavier cousin of the neutrino. But for decades, the front-runner, the one everyone's had their money on, is something called a WIMP.
WIMPs have been our prime suspect for a long time. The name says it all. Weakly interacting massive particles. They're massive, which explains all the extra gravity, and they're weakly interacting, which explains why we can't see them. A WIMP could pass right through you, right through the entire planet, and probably never hit a single thing. It's the perfect cosmic ghost.
Now, a real quick but super important clarification. It's easy to confuse dark matter with its even weirder cousin, dark energy. They might both have dark in the name, but they do the exact opposite thing. Think of it like this. Dark matter is the cosmic glue, pulling things together with gravity. Dark energy is the opposite. It's like an anti-gravity, pushing the universe apart, faster and faster. Two completely different mysteries. So if dark matter is this ghost particle that just flies through everything,
How in the world are you supposed to find it? Well, this is where scientists get really, really clever.
They're basically fighting a war on 3 fronts. First, they go deep underground, miles beneath rock, to shield their experiments from all the other cosmic junk. And they build these incredibly sensitive detectors, just waiting, hoping for that 1 in a billion chance that a dark matter particle smacks into one of their atoms. Second, they try to make it themselves, by smashing particles together at insane speeds at places like CERN. And third, they point telescopes to the sky, looking for the telltale flashes of energy that might happen if 2 dark matter particles crash into each other and annihilate.
So we're going through all this trouble, building labs underground, smashing atoms, but why? Why does it matter so much? Why pour all this effort into finding a particle that we can't even see?
It matters because of this. For every single particle of normal matter, the stuff that makes up you, me, the Earth, the Sun, there are 5 particles of dark matter out there. It's the dominant stuff in our universe. To ignore it is to basically ignore 85% of all the matter that exists.
You see, solving this isn't just about ticking a box. It's fundamental to everything. It would finally explain why galaxies look the way they do, how our universe even came to be. And the craziest part? Finding it could completely rewrite the laws of physics as we know them, opening up a whole new reality of forces and particles we never even dreamed of.
And that really brings us to the final thought here. Finding dark matter proved that our visible world is shaped by a vast, invisible scaffold. It just makes you wonder, if 95% of the entire universe is hidden from our view, what else is out there? What other invisible forces are silently shaping our reality, just waiting for us to find them?